Hi everyone, it's me, Teacher Jeanne, and in this lesson you will learn about solving linear inequalities into variables. At the end of the lesson, the learner is able to first, differentiate linear inequalities into variables from linear equations into variables. Second, solve linear inequalities into variables. Third, illustrate and graph linear inequalities into variables. Now, before we proceed, let's have a recall. Write the correct symbols greater than, less than, or equal on each pair of numbers to make the statement true. First, we have 295 compared to 592. The correct symbol is less than. So 295 is less than 592. Next, 100 over 5 compared to 20. The correct symbol is equals, because 100 divided by 5 is equal to 20. Next, 18 compared to negative 18, the correct symbol is greater than, because positive numbers are greater than the negative numbers. So positive 18 is greater than negative 18. Next, 0.25 compared to 0.75, the correct symbol is less than. So therefore, 0.25 is less than 0.75. And for the last, 1/2 compared to 0.5, the correct symbol is equals. Another, match the phrases in column A with the mathematical statements in column B. First, we have A is at most 10. So that can be written as A is less than or equal to 10. When we say at most, 10 is the highest. Therefore, the values of A are 10, 9, 8, 7, and so on. Next, 5 is less than 10. That can be written as 5 is less than 10. A is more than B, so that can be written as A is greater than B. Next, A is no more than 10. That means 10 is the highest. So we have the values of A are 10, 9, 8, 7, and so on. So that can be written as A is less than or equal to 10. Next, A is at least B. That can be written as A is greater than or equal to B. At least means B is the smallest or the least. Next, A is not less 5. That can be written as A is greater than or equal to 5. So the values of A are 5, 6, 7, 8, and so on. 3 is less than 4 can be written as 3 is less than 4. 4 is greater than 3 can be written as 4 is greater than 3. Now, let's explore. Classify the following mathematical statements whether inequality or not. Write your answers inside the box. First, we have 4b minus 2c is less than or equal to 12. That is linear inequality. Next, m plus 2r is greater than or equal to 20. That is linear inequality. Next, 3 is equal to 8x minus z. That is not a linear inequality. Next, 10 is less than b plus 5a. That is linear inequality. Next, 6r equals 3s plus 5. That is not a linear inequality. And for the last, 2y is greater than 9. That is linear inequality. Now take note, linear inequality symbols are greater than or equal, less than or equal, greater than or less than. A linear equation symbol is equals. Now, let's have the linear inequality into variables. It can be written in one of 4 forms. First, ax plus by is greater than c. Second, ax plus by is less than c. Third, ax plus by is greater than or equal to c. And for the last, ax plus by is less than or equal to c. Where a, b, and c represent real numbers and a is not equal to 0 and b is not equal to 0. Now, in linear inequality in two variables, an ordered pair xy is a solution of an inequality in two variables if a true statement results when the variables in the inequality are replaced by the coordinates of the ordered pair. For you to understand, let's have the given examples. Determine whether each ordered pair is a solution of 3x plus 2y is less than or equal to 6. So let's have the given ordered pairs. First, we have A, -1, 2. Label x is -1, y is +2. Then write the linear inequality 3x plus 2y is less than or equal to 6. Then apply substitution. We are going to replace the values of your x and y. So we have 3 times the value of your x, -1 plus 2 times the value of y is 2 is less than or equal to 6. Perform multiplication. 3 times -1 equals -3 plus 2 times 2 equals +4 is less than or equal to 6. Now perform addition. If you are going to add unlike signs, we are going to subtract then follow the sign of the larger number. So as you can see, +4 is greater than -3. So the correct answer is +1 is less than or equal to 6. So that is considered true. And if the statement is true, therefore, -1, 2 is considered a solution. Next, for letter B, we have 4, -3. First, we're going to label x is +4, y is -3. Then write the linear inequality 3x plus 2y is less than or equal to 6. Then apply substitution. We're going to replace the values of your x and y. So we have 3 times the value of x is 4 plus 2 times the value of your y is -3 is less than or equal to 6. Then perform multiplication. 3 times 4 is equal to 12 plus 2 times -3 is equal to -6 is less than or equal to 6. 12 minus 6 is equal to 6 is less than or equal to 6. And that is considered a true statement because we have equal. 6 is equal to 6. So therefore, 4, -3 is considered a solution to the given linear inequality. And for the last, for letter C, we have 4, 0. We're going to label the x is 4 and the y is 0. Then write the linear inequality 3x plus 2y is less than or equal to 6. Then apply substitution. We're going to replace the values of x and y. So we have 3 times the value of x is 4 plus 2 times the value of y is 0 is less than or equal to 6. Then perform multiplication. 3 times 4 is equal to 12 plus 2 times 0 is equal to 0 is less than or equal to 6. 12 plus 0 is equal to 12 is less than or equal to 6. And that is considered false statement because 12 must be greater than to 6. So 4, 0 is considered not a solution of the given linear inequality. Now let's proceed on graphing a linear inequality. We have the following steps to consider. First, rewrite the linear inequality as an equation and solve for the intercepts. Second, graph the boundary line. If the symbol is greater than or less than, we are going to use broken line as the boundary. If the given symbol is greater than or less than or equal, we are going to use solid line as the boundary. Third, shade the appropriate region. If the symbol is greater than or equal, we are going to shade the upper or the right half plane. If the symbol given is less than or equal, we are going to shade the lower or left half plane. Fourth, check or verify. Pick a test point on the shaded region to replace x and y in the inequality. And for the last, if the statement is true, the graph is right. Now, for you to understand, let's have the given examples. Graph 2x minus y is greater than or equal to 4. First, we're going to rewrite it as an equation. So we have 2x minus y equals 4. We're going to change the inequality symbol as equal sign. Then use x and y intercepts. To get the x-intercept, let y equal 0. Then write the equation 2x minus y equals 4. Then substitute the value of y equals 0. So negative y will be b cancel. So the remaining is 2x equals 4. Then divide both sides by 2. 2 divided by 2 is equal to 1 times x is equal to x. Then 4 divided by 2 is equal to 2. So the x-intercept is 2, and that is located on the x-axis on the right of the origin. Now to get the y-intercept, let x equal 0. Then write the equation 2x minus y equals 4. Then substitute the value of x is 0, so 2 times 0 is equal to 0. So we have the remaining negative y equals 4. Now we need to make negative y as positive, so we are going to multiply both sides by negative 1. So negative times negative will become positive y equals positive 4 will become negative 4. So the y-intercept is negative 4, and that is located on the y-axis below the origin. Now for the boundary line, if the given symbol is greater than or equal, we are going to use solid line as the boundary. Then for the shaded region, if the symbol is greater than or equal, we are going to shade the upper or the right half plane. And that is the graph of 2x minus y is greater than or equal to 4, which is a half plane. Now to check or verify if your answer is correct, we are going to pick a test point on the shaded region. So I'm going to use 5, 2 as the test point. So we are going to label your x is 5, your y is 2, then write the linear inequality 2x minus y is greater than or equal to 4. Then substitute the values of your x and y. So we have 2 times the value of x is 5 minus the value of y is 2 is greater than or equal to 4. Then simplify. 2 times 5 is equal to 10 minus 2 is equal to 8. And 8 is greater than or equal to 4. And that is a true statement. Therefore, the graph of 2x minus y is greater than or equal to 4 is correct. Another example, we have graph 3x plus 6y is less than negative 12. First, we're going to rewrite it as an equation. So we have 3x plus 6y equals negative 12. Then use x and y intercepts. Now to get the x-intercept, let y equal 0. Then write the equation 3x plus 6y equals negative 12. Then substitute the value of your y, which is 0. So 6 times 0 is equal to 0. So the remaining there is 3x is equal to negative 12. Then divide both sides by 3. So 3 divided by 3 is equal to 1 times x is equal to x equals negative 12 divided by 3 equals negative 4. So the x-intercept is negative 4 located on the x-axis on the left of the origin. Now to get the y-intercept, let x equal 0. Then write the equation 3x plus 6y equals negative 12. Then substitute the value of your x, which is 0. So 3 times 0 is equal to 0. So the remaining there is 6y equals negative 12. Then divide both sides by 6. So 6 divided by 6 is equal to 1 times y is equal to y equals negative 12 divided by 6 is equal to negative 2. So the y-intercept is negative 2, and that is located on the y-axis below the origin. Now the inequality symbol that we have there is less than. So we are going to use broken line for the boundary. Then if the symbol is less than or equal, we're going to shade the lower or left half plane. So now this is the graph of 3x plus 6y is less than negative 12, and that is considered a half plane. Now to check or verify if that is correct, we are going to pick a test point on the shaded region. So I'm going to use 0, negative 7 as the test point. So the x is 0 and the y is negative 7. Then we're going to write the linear inequality 3x plus 6y is less than negative 12. Then substitute the values of x and y. So we have 3 times the value of x is 0 plus 6 times the value of y is negative 7 is less than negative 12. So 3 times 0 is equal to 0. 6 times negative 7 is negative 42 is less than negative 12. And that is considered a true statement. Therefore, the graph is correct. Now let's proceed on the special cases. We have the given graph y is less than 2. We're going to rewrite it as an equation. So we have y equals 2, and that is located on the y-axis above the origin. Then for the inequality symbol, we have less than. We are going to use broken line as the boundary. And for the shaded region, if we have less than, we're going to shade the lower half plane. So that is the graph of y is less than 2, which is a half plane. Now to check or verify if that is correct, so we are going to pick a test point. So I'm going to use 0, -1. So your x is 0 and your y is -1. Then write the given inequality y is less than 2. Then substitute the value of y is -1 is less than 2. And that is considered a true statement. So the graph is correct. Another special case, we have graph x is greater than or equal to -3. We are going to rewrite it as an equation. So we have x equals -3, and that is located on the x-axis on the left of the origin. Now the inequality symbol is greater than or equal, therefore we're going to use solid line as the boundary. Now for the shaded region, if the symbol is greater than or equal, we're going to shade the right half plane. So that is the graph of x is greater than or equal to -3. Now to check or verify if that is correct, I'm going to pick a test point. So I'm going to use 3, 0. So your x is 3 and your y is 0. Then the given inequality is x is greater than or equal to -3. Then substitute the value of x, which is +3, is greater than or equal to -3. That is considered a true statement. Therefore, the graph of x is greater than or equal to -3 is correct. Now it's your turn. Do it yourself. Don't forget to comment down below your answer. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!